All right, last video of the four, working through each of these different problems. I'm hoping that they are helpful if you didn't understand them, and you can use them for kind of future calculations if you need. So this last one, I think on the assignment itself, I called it again 7B because I was apparently afraid of sixes. I've changed it so that there's 6 and 7, so it works. I hope that doesn't throw you off too much. But here's the question. This is following up from the baseball player in the last one who was sliding into third base. It says, what was the distance of the baseball player's slide from question 6A? So I'm going to have to see if I can remember a few things in order to help me out. The first thing that I need to remember is the acceleration from 6A. So my acceleration is the thing that we just calculated, and that was the -3 meters per second squared. So that's the first one of the things. The second thing that I need to make sure that I've got here is that I do have kind of a starting velocity, right? As I'm coming into this, we have a starting velocity. That's going to be useful. And my starting velocity is VI. This is something else that kind of was in the last problem. And that starting velocity, if you remember, was 4.5 meters per second. So that was something from the last problem. I don't think I'm going to need my final velocity, and you'll see why that's the case in just a moment. And then I also need my amount of time. So I'm going to go ahead and put in that amount of time, the duration and time of the slide. So my change in time for this problem, I might have to look it up in just a moment. The change in time was 1.3 seconds. Yeah. All right. So 1.3 seconds. I think that's all the information that I need from the last one. It's asking about what is the distance, right? So if I'm looking at distance here, this is my unknown, right? This is the thing that I'm trying to solve for. And that distance that is the unknown, I'm going to go ahead and put as a delta x. So everything else is kind of labeled here. These are all my givens, and this is my unknown. So great. Same kind of picture from the last one, but now I'm trying to figure out exactly what the distance is that we're sliding. So I'm going to go ahead and say that I've already drawn my picture in the last one. So I'm going to say my D is done. I'm going to say that my givens are what I just highlighted right here from the last problem. I'm going to say those are done. I'm going to say that my U, which is my unknown, that's right up here at the top. I'm going to say that that's done because we don't know what this is, right? And I'm all the way at the equation step already. This is really good. I'm swimming right along. My equation, I only have 3 equations to choose from. And given the fact that I've got an acceleration and I've got a change in position, and I've got this time, the only equation that I've got to work from here is this delta x equals 1/2 at² plus VI, which is my starting velocity, times the amount of time that I've got. So now you can see why I put in my initial velocity here as opposed to my final velocity, because I didn't need my final velocity in the end. This was fine based on the fact that I already know my acceleration. So now I've taken care of my writing down of my equation. I don't have to do any reworking of this, which is great because I'm solving for delta x and it's already solved for delta x. So I am now in my first one of my s's here, which is to substitute in for what I already know. So I'm going to say this is my delta x is equal to 1/2 times -3 meters per second squared multiplied times the amount of time, which is 1.3 seconds, quantity squared, plus my starting velocity, which that's over here at 4.5. So that's 4.5 meters per second. And I'm going to multiply that times the amount of time as well, which is that 1.3 seconds. So I've substituted in all of the parts that I needed, and now I am one step away from this whole problem, which is just to solve this whole thing. This is a great time to turn to things like calculators. You can do things longhand if you want to, but honestly, it's not worth your time at the moment. So I'm going to plug a few things into my handy dandy calculator just to do the same thing. And this is where calculator skills, believe it or not, can become very handy. in your math classes, they said, don't ever touch the calculator. Here, I'm like, no, no, it's okay. You can do the calculator. Point or 1/2 of 3 is 1.5. So a negative 1.5, I've already got that. And I'm going to multiply that times a 1.3 squared. And then I'm going to add on to that 4.5 times 1.3. And I get an answer out of it right here that my change, oops, let's go ahead and flip that over to black so keep it consistent here. My change in position, so that's the amount that we've slid, is 3.3. Now it's 3.315, but I'm just going to leave it here, 3.3. And then how the way my units kind of flow out is that I've got a second squared here, and those cancel over here with this second squared over there. I still have to square this 1.3, but there it is. And then this seconds cancel out here with that seconds right over there. So they're gone. So now as I look my way through, the only units that I have left are meters and meters. So my final answer is going to be here in meters. And maybe I'll write that in black just to be consistent. So my final answer here is my change in position is equal to 3.3 meters. Seems like things are going a little bit faster, doesn't it? Especially when you don't have to do any conversions and the equation's already solved for what you need. But this is what we've got. And hopefully these questions were helpful to you, these answers, however you want to think about it. And I will gladly answer any more questions that you have in office hours, and we'll chat at that point. All right, take care, everybody. Bye.